Good day, learners. Welcome back to the PSI Geography Online Classroom Series with your instructor, Mr. P. Mbuisa. Now, this is the 8th climatology session on the topic tropical cyclones. You'll remember that we've had 7 sessions so far. The first 4 were on a revision on grade 10 and 11 work. The other 3 were on mid-latitude cyclones. So this one is on tropical cyclones, and this is the first lesson of 3 on this particular topic. That is part of your grade 12 climatology curriculum. Now, please note that we are going to have 3 sessions for this topic, with the first addressing the half of the outline. So the second will be addressing the last half that we would have missed, and the third session will be an application session, just to gauge how do you respond to exam type of questions and apply the content we would have covered. So please just take note of that. So this is the first half of the session we'll be covering, and we'll cover the last half in the second session and do an application session, of course. Now, without wasting any time, let's just talk about the outline for today. So as you can see in your screen, for this topic, you basically have to know exactly what or rather we sort of covered in the previous topic, being mid-latitude cyclones. So you need to know where the systems develop, the area of development, the ingredients necessary for the system to form. So that's basically the conditions necessary for this system to form. Again, you need to know what characterizes the system. How do you identify it? So you need to cover general characteristics associated with tropical cyclones. We then also need to think about stages of development. So remember, we have the formation stage or the initial stage, and then we have the developmental stage, also known as the immature stage, and we also have the mature stage and the decaying stage or dissipation stage. So those are the stages of development, and then you notice I asserted a lot of synonyms with the stages. So just know how to identify them, what happens in each one, and all of that. We'll cover that in today's session, of course. You also need to be able to identify the system on a synoptic weather map and satellite images. So this is very important, the identification part. Just as with the previous session, we also need to look at the associated weather patterns with different parts of the system, being the eye wall, and the active quadrant, also known as the dangerous semicircle. So those are the weather patterns that you have to accustom yourself with. And then in concluding the session, of course, we'll be looking at what impact do the systems have on humans, the environment, and the economy. And of course, as we said, these systems are very dire when compared to mid-latitude cyclones. So it means we have to address how can you mitigate the impact. So strategies necessary or that can be employed to mitigate the impact of the system. So that's what we're going to be looking at. Again, without wasting any time, let's just get to it. We are covering half of the session, the part that is in red in our outline. Now, before we even go anywhere, let's just answer the what question. What are tropical cyclones? Now, answering this question wants us to think about how this is etymologically described in the name itself. So what does that mean? So the system is called a tropical cyclone, right? So it is formed by 2 words, tropical and the word cyclone. Now that is supposed to tell us something about the system itself. Going back to what we did even for mid-latitude cyclones, you'll remember that we have different lines of latitude. We have the equator, we have the subtropical high, which is at 30 degrees, and we have the subpolar low, and we have the polar high. I hope we are fine. So we have the equator at 0. My writing is skewed as always because of the mass. And then we have the 30-degree line, which is the subtropical high pressure belt. We have the subpolar low pressure belt. And we have the equator at 90 degrees. Now remember, we said 90 degrees the angle, not 90 degrees Celsius. Okay, now looking at then the systems. Now you remember with mid-latitude cyclones, we spoke about them forming between 30 and 60 degrees. So they form somewhere here. And we said they form basically the subtropical pressure belt. Or they form in the mid-latitude. So that's where the system will form. Now, thinking about it in a different gaze of things, you will know that since this is the subtropical region, between 60 and 90 degrees you have your polar regions basically. So you have your polar regions there. Yes, your polar regions there. Now, where will you find your tropical region? Now remember we said that the 0-degree line of latitude is basically the equatorial low pressure or the tropical low pressure. And that's where we usually say we find our tropical regions. Now you'll remember in session number 3 of our revision, we did cover this aspect to say we find a lot of rainforest around the equator, so it's our tropical region. So what that is telling us then is that between 0 and 30 degrees, that's basically where, or that's the basic region we will categorize as a tropical region. Now, since we are studying tropical cyclones, it simply means we are studying systems that will form in your tropical regions. I hope we are fine with that. So the tropical is basically giving us an idea where does the system form. Okay, now let's pause from that. Let's talk about the second word. It's cyclones. Now, what does cyclone mean? Think about the revision session and number 3. We did cover the difference between cyclones and anticyclones. We said a cyclone is a low pressure system associated with warm air that is rising. And we said this air is less dense. And because it's less dense, it will cool down as it rises, and it will lead in unstable weather, which means you would expect precipitation with this kind of system. So since we are studying tropical cyclones, we are basically looking at systems that will be associated with unstable weather conditions. Now, I hope we are fine with that. We were just talking about random stuff that we had covered in the previous sessions. Now, looking at our notes then in the outline here. Now, a formal definition goes as follows. We say a tropical cyclone, number 1, it's a low pressure system because it's a cyclone. Fine. And we say it's a low pressure system that occurs where? In the tropical regions. And we say it is characterized by their formation where? In warm oceans. So again, out of common sense, since we have the highest temperatures in the tropical regions, we'll expect to have warmer oceans or warmer ocean currents as well existing in that particular region. Now, we say these systems will lead to immense storms. And remember, immense storms are due to unstable weather. And why do you have unstable weather? Because we are looking at cyclones, low pressure systems, which are associated with this unstable weather. So I hope we are fine. So that's what a tropical cyclone is. Now, where do they form? We've sort of covered that already to say they form in the tropical regions, and that is between 0 and 30 degrees. Now you'll notice that my outline here says they form between 5 and 30 degrees, both north and south. Now let's just talk a bit about why don't they form between 0 and 5. Now when we were covering the types of cyclones and characteristics that come with cyclones, we did say that for these systems to really work out, we need to have air conversions. So what do we mean by that? It means we need to have air moving towards the system. So that's what we mean. Now, for air to move towards the system or to be deflected towards the system, we need to have a specific force known as the Coriolis force. Now, the Coriolis force is the one that is responsible for the deflection of winds. I hope we are fine with that. And remember, the Coriolis force will deflect the winds as per Ferrel's law. Ferrel's law says air will be deflected to the left in the southern hemisphere and to the right in the northern hemisphere. Now, so that's what we need. So between 0 and 5, we do not have the Coriolis force. That's why your system will not form over there. Between 5 and 30 degrees, you do have the Coriolis force, and hence you are gonna have the system developing over there. Now, in what general direction is it gonna move? It moves from the west to the east. From the east to the west. Remember, mid-latitude cyclones move from the west to the east, so they move from east to west. Why? Because they are located in the tropical easterly wind belt. So that's where the systems will form. And of course, just as mid-latitude cyclones have alternative names, tropical cyclones as well do have alternative names. So they are first known as hurricanes. You know how people in the northern hemisphere like being fancy about this stuff, so to give them such a fancy name, hurricane. So the country here is just showing in what parts of the world do they use that name. So they usually affect the Gulf of Mexico, and in Japan and Eastern China they call them typhoons, and in Africa and Australia we call them tropical cyclones. So those are the systems we have, those are the alternative names they have. I hope we are fine with that. So now I want us to then talk about general characteristics associated with the systems. In thinking about general characteristics then associated with these systems, one has to first look at in what parts of the world do they affect, because that sort of influences the system itself, or the characteristics that will be associated with this system. Now, if you look at the diagram then on the screen, it is telling us certain features or certain characteristics that this system will have. And the first thing that we notice from the diagram then is that it has a specific key, right? So it has the orange color, and the orange color basically represents areas in which the tropical storm will typically form, right? And it also has the arrow, the white arrows. So the white arrows are basically showing us the typical pathway of this tropical storm or tropical cyclone. And if we were to look at these then in our map over here, we see that the general movement of the systems is from that direction going into that direction. So what does that mean? So it is telling us the system will be moving from the east and it's going towards the west. Now remember, sorry about that. Now remember, your mid-latitude cyclones will have a different general movement. So they have a different general movement. What causes that? Remember, they are located in the easterly wind belt. And the easterly wind belt, remember, it's between 0 and 30. So your tropical cyclones are in the easterly wind belt between 0 and 30 degrees, while your mid-latitude cyclones are in the westerly wind belt, which is between 30 and 60 degrees. So because of this, your tropical cyclones will generally move from the east to the west. And why? Because they are driven by tropical westerlies, or winds that are formed in the tropical easterly wind belt. So I hope we are fine with that. And we see that the systems themselves also generally will form next to the equator. And I'll say that part also explains why we say these are cyclones, right? So they are low pressure systems, because they form in our warmer regions or our tropical regions. So that's what we gauge. And of course, just to add on what we talked about, is that these systems have alternative names. So in those parts of the world, they're known as hurricanes. In parts of Asia and Japan, they're known as typhoons. And in Madagascar and Africa, they're known as tropical cyclones, right? So those are the alternative names, and of course they form next to the equator, not immediately at the equator, so 5 degrees outside the equator. So let's just look at more characteristics to build up on this. Now, the first general characteristic is that the system is associated with an intense low pressure. So remember, with mid-latitude cyclone, we said they are associated with an extensive low pressure. So for this system, pressure really plays the key role. It has to be really, really low, below 950 hectopascals. So that's how intense the pressure has to be. So it has to be below that mentioned figure. And the systems will occur late summer and early autumn. So they will occur around January, February, and early March, right? And where do they occur? They occur over warm oceans. So if you remember the diagram before that we looked at, it showed us that the system is forming in your warmer oceans. And remember, that's your Indian and Pacific Ocean. So they form in your Indian and Pacific Ocean because those are your warmer oceans. They don't necessarily form in the Atlantic Ocean. So let's also remember that. Another one is that the air around the system will circulate in a clockwise direction, where in the southern hemisphere, and in an anti-clockwise direction in the northern hemisphere. And they are also associated with a steep pressure gradient, which means we have more vaporization of air as a result, and that may cause them to be associated with very strong winds. And as we said, they move from east to west. And why? Because they are driven by tropical easterlies located in the easterly wind belt, and they consist of the eye, which is basically the low pressure center of the system. So that's the eye, and this eye, remember, has no cloud cover, no winds. So we have stable conditions in the eye. We'll talk about that more in depth. They are also associated with strong winds. The two vortexes of the systems are associated with very strong winds. And what we mean by that is we mean that these winds travel up to 300 kilometers per hour. So those are intensely strong winds that we are looking at. They are also associated with high cumulonimbus clouds in the wall of the eye. We'll talk about that when we look at associated weather patterns, of course. And of course, they're associated with heavy rainfall, hail, storm surges, and strong winds. So they are associated with all these conditions. And remember, we give them names. Unlike mid-latitude cyclones, these are given names. Tropical cyclones are given names, and we name them alphabetically from A to Z, which means the first one to occur will have your lower alphabets, and the last to occur will have higher, or latest, most latest to occur will have your higher alphabets. For example, in this year 2022, we are affected by tropical cyclone Ana, and last year 2021 we were affected by tropical cyclone Eloise. Which means there were 5 others before Eloise, right? And since we have Ana, it means Ana is the first one because it has the letter A. So those are some of the features they have. They affect the east coast of continents. So why do they affect the east coast? Simply because they move from the eastern side to the western side, so they are going to affect the east coast, and they don't necessarily get to the western side because they dissipate or get or decay rather before they could reach that side, because remember, they need to be in warm oceans for them to form. So as I said, in warm oceans, so they move only over oceans, and what happens when they get to land? They die out. And why? Because there is friction and there is lack of moisture. Yeah, so we don't have latent heat, but we have terrestrial heat inland, and these systems need latent heat for them to form, and moisture, a lot of moisture. And we know that when you compare the evaporation rate in the ocean with one on land, we know that the ocean has a higher evaporation rate. So I hope we are fine with that. So those are the general characteristics that the systems will generally have. Now let's think about conditions necessary for them to form. And remember, I always say with this section of work or this part of understanding your information or knowledge about the system wants you to think about it in this way. You think about what ingredients are necessary for the system to have, what prior conditions have to be in place for the system to fully form, what are the most conducive conditions that will enable for the systems to form. So the first one then is that the location of the system affects whether it's gonna form or not. Now the first thing is that these systems need to form 5 degrees north and south of the equator. So they need to form 5 degrees outside the equator. So they form between 5 and 30 degrees. And why? It's because for them to form, we need to have the Coriolis force. So the Coriolis force must be present. And what is the Coriolis force? It is the force that causes the deflection of winds. And remember, this force deflects winds following Farrell's law, and Farrell's law says air will be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. So now the Coriolis force needs to deflect the winds, and remember, the deflection of winds enables for the vortexes to form, and the first and the second vortex of the system to form, and for a full-on cyclone to form, as a tropical cyclone to form as a result, right? And we also need ocean surfaces. That's another ingredient. This system cannot start on land. It can only start on ocean surfaces. And why? Because they are frictionless. So we do not need friction. We need an ocean surface. So that's where they form, and the temperature of the ocean needs to be more than 27 degrees Celsius. Remember, some of your textbooks will say it needs to be 26.5 degrees Celsius and above. That is also acceptable. The point is that they need to be above 27 degrees Celsius or 25 26.5 degrees Celsius, as most of your textbooks will say. And what else do we need? We need to have hot, moist air. Due to what? Due to latent heat and rapid evaporation. Remember, guys, latent heat is, in simple terms, basically heat that is stored in water as this water gets evaporated. And we also need rapid condensation. So this heat will lead to rapid condensation, of course. So that's another condition we need to have in place. And we need a lot of surface air conversions. Remember, we're looking at systems called tropical cyclone. So we need surface air conversions, and these surface air conversions will lead to the formation of vortexes. So we need to have this happening, our air moving towards a central point or converging. Remember, in a low pressure, it does that. And remember, as much as this air is converging, because of the influence of the Coriolis force, it is also going to be rising, because warm air always rises, right? So it is going to rise. And of course, your pressure gradient force will act in the upper atmosphere and will lead this air. Remember, as it rises, it's gonna cool down. So because it cools down, divergence will occur in the upper atmosphere. And what you'll have then is that around the system or the center of the system, you'll have what? You'll have clouds forming as a result. So you'll have clouds forming as a result. And we say these are cumulonimbus clouds. So you'll have cumulonimbus clouds forming around the system, especially around the eye wall. And why do we say this is the eye wall? So remember, you'll have your highest pressure in the upper atmosphere, and we know that as this air goes down, the lower you go, the warmer it gets. So it is going to heat up adiabatically, but since this air is dry, it will make the eye to not have cloud cover, strong winds, and no precipitation at all because of that, because we have air that is cold and dry from a high pressure sinking, and as it's sinking, it is warming up adiabatically, which means for every 100 meters it travels down the eye, it will increase in temperature by 1 degree Celsius. So that's what we need for that to happen. So remember now, this first section of the cyclone, we call that the first vortex, and the second section of the cyclone, we call that the second vortex. So let's remember that. So this is your first vortex, and this is your second vortex. So that's what I mean by saying vortexes will form. So that's your second vortex, and remember, this is the eye. So the center of the system is known as the eye, and we said the eye does not have cloud cover, rainfall, or any form of precipitation. So that's your eye. Sorry for the skewed writing, as always I'm using a mouse. So but I hope we get the point. So that's what you will need for the system to form. So what you see on your diagram then is a fully formed tropical cyclone in the mature state. So it will look like this, and all of those conditions to be formed, to be met, of course. And we also say we need what? Upper air divergence. So that's exactly what I described up here. So the two arrows there, they are showing us we have upper air divergence. So we have lower ocean surface convergence. So remember, this is the ocean surface, and as air converges, it also does what? It also rises, right? Because warm air will always rise. Remember, we're still applying our golden rules, and remember, this upper air divergence will lead to condensation, because remember, this air will be moving from water vapor status back to liquid status. water vapor status, which is a gas, back to liquid status, and this condensation will lead to the formation of clouds and rainfall as a result. What else do we need? We need an intense low pressure cell at the center of the system. So that's what I described there. And what enhances this intense lower pressure cell is your tropical jet stream in the upper air. So your tropical jet stream in the upper air is what leads to, or is what enhances your intense low pressure cell. Remember, your jet stream is basically a global winds that will move from high pressure to low pressure in the upper atmosphere. So they encourage the system to be fully developed as a result. Okay, so now let us then think about the stages of formation, right? Stages of formation. So we have 4 different stages. Now the first stage we have is known as the formation stage. Now what happens in the formation stage? Now remember I said the system is oriented around pressure. So we are going to look at the stages in detail. For starters, I just want to talk about the stuff generally, so that when we look at diagrams and the representation thereof, we can fully grasp what we're looking at. And my apologies for background noise if you guys can hear it. I am in a school, so apologies for that. So going back to it, so in the formation stage, remember I said pressure drives the system. So in the formation stage, we have a very basic thing happening. So in the formation stage, that is when the system is still forming, right? So our pressure will be above 1000 hectopascals, because that is in a way before the system matures, right, or fully develops. So your pressure is 1000, is above 1000 hectopascals. Yeah, so that's what you have in the formation stage. So let's just leave it there. So we have pressure above 1000 hectopascals, and it means our temperature is not above 27 degrees Celsius, which means it is not as high as of yet, so it is relatively lower in the formation stage, right? But we notice that as this stage progresses, our temperature starts to increase slightly. And remember, as they increase, the pressure will also start decreasing, because the two are inversely proportional or opposite to each other. So it takes us then to the immature stage. So in the immature stage, our pressure is starting to decrease. So it is basically starting to be below. It's starting to be below this 1000 hectopascals, right? So it's starting to be below this 1000 hectopascals. Yeah, so I'm just gonna do these dashes to show I'm looking at the same thing. So it's below 1000 hectopascals. That is what happens in the immature stage. And of course, you start having some conversions of air, which will lead to slight formation of vortexes and all, but the system is not distinctly formed. And what happens is that now in the mature stage, the pressure now is well below, so it is well below 1000 hectopascals. So it is well, I'm gonna do these D dashes, well below 1000 hectopascals. So it is well below 1000 hectopascals. So remember guys, these double lines, the 11 like sign, means what we mentioned above is the same as what you should have below. Yeah, so your mature stage, your pressure is well below the 1000 hectopascals, right? So it means it is somewhere in 950 per se. And that's where you have the most intense pressure at the center of the system. And because of that, now you will then have all the condition, the eye being fully developed, the vortex is being fully developed, and tropical storm or hurricane strength winds and all of the conditions associated with that we are going to talk about in the next session. And then the last stage is the dissipation stage, of course, as you can see. Now, dissipation stage is caused by the system getting to the land. When it gets to the land, our temperature starts decreasing, right? Because as we said, the ocean will be more warmer than the land. So when temperature starts to decrease, and we have less moisture now, and more friction as a result, we now start having an increase in pressure, right, at the center of the system. So we have an increase in pressure, and this increase in pressure is what is responsible for the dissipation or the decaying, or for the system being destroyed. Yeah, so increase in pressure. My writing is so terrible, but I hope we get the point, right? Yeah, so we have an increase in pressure. Sorry for spelling there. Yeah, so we have an increase in pressure and system gets destroyed. So let's then look at the stages in more detail, right? So in the formation stage, what will happen is convergence of air towards a low pressure creates what? A vortex, right? So we have air starting to converge around the low pressure, and this creates distinct vortexes. And of course, as I said, the pressure is above 1000 hectopascals, so it is at about 1002 hectopascal. Remember, these are estimations, but if you look at the diagram here, it's showing us exactly that. So pressure at the center is relatively higher, and the wind speed is 60 kilometers per hour. So we still have slightly weaker winds, I hope we saw how the clouds also look. They are a bit scattered and not fully formed. And in the immature stage, the intensity of the storm increases, and what causes that? The convergence of air as it rises, and the low pressure cell also intensifies. And we know that divergence starts happening in the upper atmosphere, while convergence is happening where? In the ocean surface. And this creates your vortexes, right? And you have air pressure dropping to below 990 hectopascals at the center of the system, and the wind speed also increases. And why does it increase? Because the pressure gradient force is also relatively increasing, right? And the eye starts to form at the center of the system. It is not as well developed as you like, but at the center of the system you'll expect fragments of the eye forming, and of course huge cumulonimbus clouds form around the eye. So if you look at the systems over here, we have clouds, dense clouds forming over there, and this is showing you the pressure at the system is starting to relatively decrease in the immature stage. And of course you'll expect that in the mature stage the storm will reach maximum intensity, right? And it means you have intense pressure that is about 950 hectopascals, and your wind speed will reach the highest strength higher strength, and they will exceed 180 kilometers per hour. Remember, they go up to 300 kilometers per hour. They're very strong, associated with catastrophic conditions. And of course, the eye is fully developed, right? Eye fully developed where? At the center of the system. And remember, the characteristics of the eye is that in that region there are clear skies, so it is cloudless, and we have cooler air subsiding from the upper atmosphere. And we say as it subsides, it is heating up adiabatically, and that is what will cause the eye to be without a cloud cover, as you can see in that image, satellite image there on the side. And that the eye is what I highlighted in yellow. So that's the center of the system, and you can see cumulonimbus clouds. They are dense, they are surrounding the eye, and they are associated with the most intense, devastating conditions as a result. And your first and second vortexes are well developed. So let's also remember that your cyclone winds exceed up to 600 kilometers in diameter, so they cover the largest regions, and can bring, of course, terrestrial rainfall, coastal flooding, storm surges, thunder, lightning, and the most severest of conditions that you can think of. So let's remember that. Now, within the cyclone itself, I hope we can see, we have a section of the cyclone that is known as one that has the most severe weather, and we call that the dangerous quadrant, or the dangerous semicircle, as some textbooks will call it. So that's a part of the cyclone that has the strongest winds, the densest cumulonimbus clouds, and the most catastrophic conditions. And so that section of the cyclone is usually found in the first vortex, right? And remember, if you compare the two, between the first and second vortex, the most catastrophic vortexes will be the first one, because it has this dangerous quadrant. And of course, we are going to talk about it and the associated weather patterns with this quadrant in our next session, lesson number 2, on associated weather patterns and the impact thereof. So that's what happens in the mature stage. Remember, guys, this is how you identify the mature stage on a satellite image. The eye is fully developed, well formed. In your synoptic weather map, you'll have such isobars. It will look something like that in your synoptic weather map. So be able to identify these, and then let's just build up on the mature stage to just be more practical about it. Now, if you look at the diagram that is shown over here, so it's showing us exactly what will happen. If we remember, we were looking at a top view in the previous diagram. So remember, we said as a condition necessary in the mature stage, we first talk about what? We talk about us having a warm ocean. So when you have a warm ocean, what will happen is that we will have upper air conversions, as you can see here. And after this air converges, it is going to rise, right? Because there's a low pressure. So because of these conversions, a low pressure will form. And after it has risen, it's going to rise, right? After it has converged, it rises. And as it rises, it's going to cool down. And as it cools down, it condenses and forms the clouds that you see over here, right? And now diversions will happen in the upper atmosphere, as we said, and of course, as this air diverges, it will form your clouds, or condense, form clouds, and the coolest air, which will be more dense, will sink, as you can see on that side of the diagram. it will sink, as you can see on the sides of the diagram, get warmed up, rise, so the humidity is kept within the systems, within this closed system, and as a result, of course, you are gonna have very severe storms forming as a result, and you are gonna have rainfall. But now something different happens at the center of the system. Remember, we talked about jet streams, right? Jet streams will encourage this. So your jet streams will encourage air to move, or winds to move from high pressure to low pressure. And as a result of this, the coldest air will sink at the center of the system. Now, remember, we know that the rules say the lower you go, the warmer it gets, and the higher you go, the colder it gets. So since the warmer you go, the lower you go, the warmer it gets, or your temperature will increase with a decrease in altitude in a more formal sense. What that means is that as this cold air from the high pressure at the top sinks, it warms up adiabatically, which means for every 100 meters it travels down or down towards sea level, or for every a decrease in altitude of this cold dense air, it is going to increase in temperature. So by the time it reaches the surface, it will be hot air, or relatively warm air, that is dry, because cold air is relatively dry without moisture. So that's why in the eye you will not have cloud cover, you will not have precipitation, you will not have strong winds as a result. So we say you have stable weather conditions at the center of the eye. So let's remember that. So that's what will happen in the mature stage. And if we were to then look at a 3D kind of a diagram to show what will happen, it shows you that in the ocean you'll have rising air, so it rises, and as it rises, of course, it's circulating in a certain way. So this is in the northern hemisphere. So that's why this cyclone is circulating in an anti-clockwise direction. So as it is rising, what will happen is that you are going to have the formation of clouds in the first vortex and the second vortex, at the center of the system, as the two arrows are showing, you'll have sinking air in the eye that will be warming up as it sinks, and we call that adiabatic heating, of course, and that's how your system will look like as a result. So that's the mature stage. Then let's talk about the dissipation stage. Now remember, we said in the dissipation stage, what will happen is that air cools down as it gets to land, and this will decrease the latent heat released, right? Because remember, the latent heat fuels or powers up these systems, right? And why does the latent heat decrease? It's because the system is moving over land. So now we are now gonna have cooler air flowing into the cyclone. And remember, when we have cooler air or colder air, the pressure will increase to above 1000 hectopascals. And as a result of that, the system will get destroyed. So when the system gets destroyed, because it is no longer a tropical cyclone, right? It's becoming an anticyclone because pressure is increasing. And again, we can think about another factor to say, as it moves inland, the supply of moisture, remember it was the ocean, gets cut off, and the smooth ocean surfaces go away. So we have now surface friction, and this slows down the movement of the system, and as a result, the system will be destroyed. And remember, guys, when it gets destroyed, you still have storms associated with it, right? You still have storms, but they are not as intense as you will expect them to be. they will not be as strong as you expect them to be in a tropical cyclone. So let's remember that. So that's what will happen. Yeah, so that's what will happen, and the system will get destroyed once more. And in a synoptic weather map, you will see pressure, circular isobars or oval isobars, and pressure that is slightly higher shows us that it's in the dissipation stage or decaying stage. And in terms of a satellite image, you see that the eye is destroyed, so we don't have the lowest pressure anymore. So the clouds are a bit scattered over there. So in this case, you'll say the dissipation stage or the decaying stage is more or less similar to a satellite image of the immature stage or the formation stage as well. Yeah, but let's say the image more similar to the immature stage, due to how the clouds will be. Because the eye is not fully developed, so it's been destroyed. And again, another piece of evidence I will show is in the dissipation stage. If you look at the land, you see these clouds are further inland and not on the ocean per se. So it shows us that it is inland, it's dissipating, it's getting destroyed as a result. Okay, so now let's just look at an animation of the system on a satellite image. So this is showing you an image of the system, and remember, now you will be asked in exams to talk about the circulation of air in the system, and we see that in this one the air is circulating in an anti-clockwise direction. So air is basically circulating like that in this system. And what is that telling you? It is in the northern hemisphere. So be able to look at the band of clouds to identify the circulation of the air. So this is how the system would look. Now let us then think about even more satellite images. So remember that was showing us the system in the northern hemisphere, right? Because of the circulation. So it was an animation, of course. Now let us look at an image, a depiction of what I was looking at that side. So we see that we have satellite images. Remember, in part 4 of the revision, grade 11 and 11 revision, we looked at how to interpret satellite images. So we see that that you'll always get a satellite image that is black and white, right? So I've just attached one that is in color and one that is black and white, and it's the same diagram really. So you see that this system is moving towards the land, and it is circulating in a certain way. And from the looks of the clouds, it's still anti-clockwise, so it's showing us it's in the northern hemisphere. And now you see the colors, guys. Remember, I said the darker black colors represent your water and fragments of vegetation on land, right? And the light gray, that's showing us what? That's showing us pieces of the land, right? The light or dark gray colors, if you want to put it like that. And we see that as well, the clouds are white. They are still white in a black and white image. So you need to be able to identify these on satellite images. So as much as you need to be able to identify this on satellite images, you also need to be able to identify this on synoptic weather maps. Now remember, we said they are given what? They are given names. So if you look at that is tropical cyclone CYCLONE. So it's tropical cyclone CYCLONE, and it has the letter, it starts with the letter G. Now they may ask you in which, looking at the name CYCLONE, how many tropical cyclones have occurred before tropical cyclone CYCLONE? So you then gonna say 6, because CYCLONE is the letter 7, right? It's a 7 letter. G is a 7 letter, so it means 6 have occurred before it. So that's that. And again, they will ask the season. What season is depicted here? You'll say it's summer. Why? You see, this is February. The 17th, so that is late summer, for example. And we say these systems occur late summer, early autumn. Yeah, so you need to be able to again interpret your satellite images for the system, and remember, look at the symbol that is shown there. That is the symbol of the eye. So that's one piece of evidence again that you can use as well. Now let us summarize then everything we've covered. So I hope you understand how to read and identify systems on satellite images and on synoptic weather maps. So in summary, we said tropical cyclones are low pressure systems associated with severe storms. So they are low pressure systems associated with severe storms, strong winds that occur when late summer, early autumn. And they are associated with what? Intense low pressure, the eye, and vortexes. So those are very important parts of the system. And where do they form? They form over the ocean, and specifically warm oceans. And what happens when they get to land? They die out due to the conditions being unfavorable on land. So those are your tropical cyclones, and of course you need to know the stages of formations of these systems, and identification of these systems on synoptic weather maps and satellite images. So that is the end of our first lesson for today. Now, in coming up in the next lesson is again a topic, tropical cyclones. Over there we are gonna be looking at the mature stage in more detail. So we'll be looking at what associated weather patterns do these systems come with, what happens in the eye, what happens in the vortexes, how do you identify those, how do you intensely explain how they will form, and what is their impact on the environment, the economy, and on human activities as well. So we are going to be looking at those, and of course we are going to be looking at some aspects that you may not have in-depthly understood in our first lesson of tropical cyclones. Feel free to replay this video just to reinforce and show you fully understand the knowledge you expected to know for this topic as per your examination guidelines, and ensure that you take notes as you are watching the lesson, and you keep on studying the sessions, or rather the different sections associated with this topic. Feel free again to share this video with your friends that are in grade 12, your teachers as well, so that you can watch these lessons in class, or as study groups and so on, and so forth. Because remember, for you to do really well in grade 12, you need to understand the scientificness of this work and know how to apply it in different aspects and different questions that they may ask in the examination. So without wasting even more time, please remember, I am your instructor, Mr. P. Mbuisa. It was lovely to have you in this lesson of my online classroom from the Pedagogical Science Institute School Student Support Program online classroom series. Thank you again. Bye.
Audio Jungle.